Okay, this is lesson 9-1, video 3. I am on page 591, and we are now going to look at the formula for finding the area of rhombuses and kites. Fortunately, these two shapes share the same formula, and that formula is area equals 1/2 diagonal 1 times diagonal 2. Let's look at that. Here is a rhombus, and we have diagonal 1 and diagonal 2, and to find the area, it's pretty easy. We just say 1/2 diagonal 1 times diagonal 2. Same thing with the kite. Area equals 1/2. Multiply this segment by this segment. All right, if you want to understand how that formula is derived, you can look right above it and read this paragraph and follow the math here. It's really pretty easy algebra, and these diagrams go with it. I'm not going to take time to do that, but you might want to do that, and that's completely up to you. You don't need to, like, for test or anything. Okay, let's apply the math on this. So the first thing we need to do is example 3A. Y'all, I'm so sorry. I'm trying to move my notebook, move the book, get the phone in the right place, and I utterly failed. All right, example 3A. So we are finding the second diagonal, or diagonal 2 of a kite, in which diagonal 1 is 16 centimeters and the area is 48 centimeters squared. So let's look at my notebook. All right, it said diagonal 1 was 16, so we'll make this going right across here. And I said the area equals 48 centimeters squared. And of course this is centimeters, but I'm going to leave that out of the diagram. Okay, so our formula is, and this will have to be memorized, area equals, all of these formulas will have to be memorized, by the way, just a reminder. Okay, area equals 1/2 diagonal 1 times diagonal 2. So we have our area. We need to plug that into the area spot. 48 equals 1/2, and then diagonal 1 was 16, and we're solving for diagonal 2. I'm going to leave the 2 off since we just have one D now. Okay, we can do 1/2 of 16, which is 8, and we have 48 equals 8 times D, bringing that D down. And then to get D alone, we're going to have 48 divided by 8, which equals 6. And remember that this is centimeters. You do need to label these answers. You also need to show all of your work in these problems. Let me think through that for just a second, including the formulas. So each problem you do needs to start with a formula and then show the work all the way through in order for you to get full credit. I would also encourage you to do that on your test for helping you remember formulas, but also for showing your work and getting partial credit where appropriate. Okay, this is example 3B. I'm now at the top of page 592, and we're going to find the area of the rhombus in the picture. So we know the area equals 1/2 diagonal 1 times diagonal 2. I actually did those backwards just now. Diagonal 1 times diagonal 2. So let's try that. Diagonal 1 is 6x plus 4. Diagonal 2 is 10x plus 10. So we're going to say area equals 1/2. And diagonal 1 was 6x plus 4. Diagonal 2 is 10x plus 10. Okay, now you may notice that we have two binomials, and the way that we deal with those mathematically is to FOIL them. So we'll multiply the first, and then the outer, and then the inner, and then the last, the 4 and the 10. So let's do that first. We're going to have 60x squared for our first, and then plus outer, which is 60x, plus inner, which is 40x, plus last, which is 40. Let me double check my math on that since y'all aren't sitting here to help me with it. Okay, and then we can combine the middle terms. So we're going to have 60x squared plus 100x plus 40, and we have 1/2 of that as part of the formula, and area equals that. So area is going to equal the 1/2 distributed to the whole problem. So if we take half of everything, that's going to be 30x squared plus 50x plus 20, and I think that will be our final answer there, except for labeling it. Yes, it is. And the problem was in inches. So we are going to have inches, and this is area, so that's dimension times dimension, so that is squared. And that's the final answer for 3B. Now let's look at 3C. We're going to find the area of the kite, and this one is going to require just a little bit more of us. So let me flip to a clean page in my notebook. All right, here we are given, you know what, y'all, for the sake of time, I may need to try to talk you through this and not do the math. It's all math that you're familiar with. So let's get going on it and see what we can do. Remember, the area is going to equal 1/2 diagonal 1 times diagonal 2. But if you'll notice, we were not given anything but this outside part of the kite, this outside part of the kite, and this one section of one of the diagonals, and then X and Y. So let's look at how I labeled everything in this picture. I knew that this part of a kite is congruent to this part, so this is 41. I knew that this part is congruent to this part, so the top is 15. I knew that if this was 9, that this was also 9. And I needed to start solving for other pieces. Now, if you'll notice, I have a triangle right here. I have 4 triangles, 1, 2, 3, 4, and I can use the Pythagorean theorem on some of these to find the missing pieces. So in this case, I could say a squared plus x squared equals 41 squared, and I solved for 40, and that is done in your book. I think I said 8, I meant to say 9, I'm sorry. 9x squared plus 9 squared plus x squared equals 41 squared, and then we solve. X equals 40. And then we can do the same thing right here in the little triangle. We have the hypotenuse, we have this leg, so we can say 9 squared plus y squared equals 15 squared, and that's done right here, and we solve and get y equals 12. So then we know that this part of the diagonal is 12 and this part is 40 based on using our Pythagorean theorem. Now we have our 2 diagonals. We have diagonal 1, which is 40 plus 12. Don't overlook the fact that we had to combine segments here to have the whole diagonal. So 40 plus 12 is 52. And don't overlook that here we had to combine 9 plus 9 equals 18. So our formula is going to be area equals 1/2 52 times 18, and that is done right here for you, and there is your final answer. All right, there is a check it out, number 3. I'm going to pause over it so that if you want to work the problem and practice, you can see how I worked it and double check and make sure that you're understanding. And now, if you will look with me at example 4. Okay, so example 4, I am sad to say I meant to come back and study before I did the video. So I'm trying to decide if I can wing it or if I need to pause and start a new video. Let's try it. Let's see if I can do it without going over it before I do. All right, this is a tangram. The pieces of a tangram are arranged in a square in which the side equals 4 centimeters. So let's look at it. The whole side equals 4 centimeters on each side because it's a square. Now from that, of course, I was able to glean that the side of each little square is 1 because 1, 2, 3, 4. 1, 2, 3, 4. So each side of each little square is 1. And it says use the grid to find the perimeter and area of the red square. So what we're going to do here is we are going to need to find out how long the diagonals are in this picture. So to do that, I used my little square down here where I had said that each side was 1, and I solved using the Pythagorean theorem. I said leg squared times, I could have used this leg right here, leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. And when I did my Pythagorean theorem, my hypotenuse came out to be radical 2. So all I need to do there is apply that thinking that each diagonal is radical 2 to the red square. And how do you solve for perimeter? Perimeter is side plus side plus side plus side, Or in the case of a square, it's 4 times side, or 4s. So what is 4 times radical 2? Well, unless we're going to do decimal numbers, that really is as far as we can go with that problem. Simply saying 4 times radical 2, which is 4 radical 2, and its perimeter, so it is centimeters, not centimeters squared. We did not multiply a dimension by a dimension, so we simply have centimeters. All right, now we also need to find the area of the red square. So let's look at that. Area is length times width, or base times height, or in the side of a square, side times side. So we usually think of an area as being side squared. Now, y'all hold on just a second, let me think about this. Yeah, okay, so I would simply say area equals side squared. In this case, that's radical 2 squared, which is simply radical 2 times radical 2, which equals radical 4, and the square root of 4 equals 2. We also could have done it the way that they did. They treated the red square as a rhombus and said that would be 1/2 times d1 times d2. Or, so what they're looking at there, whereas we solved for the outer edges, they're using the diagonals, and we know that each line on this grid is 1 centimeter. So they're saying this whole diagonal is 1 plus 1 or 2. This whole diagonal is 1 plus 1 or 2. So the formula is going to be area equals 1/2 diagonal 1 times diagonal 2 equals 1/2 2 times 2. 2 times 2 is 4. Half of it is 2, and we get the same answer, 2 centimeters squared. All right, there is a check it out. I'm going to do the same thing that I did on the last one in case you want to try it. I'm just going to pause over it, and you can pause and try the problem and see if it comes out correctly and see how I solved it. All right, I hope that this set of videos was helpful, and I think you'll do great on this homework. It is a long lesson, but I don't think it's a tricky lesson. You just need to remember that some of this is going to be multi-step, pulling together things that we've learned in the past. Hope y'all have a good day.